Imagine you're standing on a beach somewhere in the world, maybe the Mediterranean coast, maybe California, maybe Thailand. You're looking out at the ocean, watching waves roll in like they've done for millions of years. Now picture this. Walk out into that water. Keep walking. 400 feet down, straight down beneath those waves, you'd find something incredible. The remains of forests, river valleys, caves where humans once lived. Entire landscapes that were above water just 12,000 years ago. Now drowned, gone, buried under hundreds of feet of seawater. This isn't science fiction. This actually happened, and it happened fast. If you're using this to fall asleep, perfect. That's exactly why I make these. So maybe subscribe and tell me where you are and what time it is. I check the comments and it's always fascinating. Sydney at sunrise, Seattle at midnight, Stockholm during lunch break. All of us scattered across this planet that was once a very, very different place. Today, when we look at a map of the world, we think this is what Earth looks like. These are the continents. These are the oceans. This is normal. But 12,000 years ago, if you had a map, you wouldn't recognize it. The coastlines were completely different. The sea level was 400 feet lower than it is today. That's the height of a 40-story building. Entire regions that are now underwater were dry land. Indonesia wasn't a scattered archipelago. It was a massive subcontinent called Sunderland, connecting what are now islands into one huge landmass. The British Isles weren't islands at all. You could walk from London to Paris without getting your feet wet. The Persian Gulf didn't exist. It was a river valley where people lived, hunted, built settlements. And then it all drowned, not slowly, not gradually over millions of years like the patient geological processes we usually think about. Fast, catastrophically fast. Within a few thousand years, maybe less, sea levels rose by those 400 feet. Imagine what that means. Every year the ocean creeping further inland. Every generation, stories of grandmother's village that's now beneath the waves. Every century, entire regions swallowed by rising water that just kept coming and coming and coming. This is the Great Flood. Not the flood. The actual, geological, scientifically documented flood event that reshaped the entire planet around 12,000 years ago. And here's the thing that keeps scientists up at night. Nearly every ancient civilization on Earth has a story about it. The Mesopotamians told of Gilgamesh and a flood that covered the world. The Hebrews wrote about Noah. The Greeks had Deucalion. Hindu texts describe Manu surviving a great deluge. Chinese mythology tells of Gun Yu and catastrophic floods. Indigenous peoples of the Americas, from the Pacific Northwest to the Amazon, have detailed flood narratives. Australian Aboriginal stories describe the sea drowning the coastal lands. These stories come from cultures separated by thousands of miles and thousands of years, cultures that had no contact with each other, and yet they're all describing the same thing: water rising, destroying, reshaping the world. For a long time, historians dismissed these as pure mythology, symbolic stories about the power of nature or the wrath of gods. But then geologists started reading the rocks, and the rocks told the same story the myths did. Something extraordinary happened around 12,000 years ago, something that ended the last ice age in a burst of melting ice and rising seas, something that may have wiped out megafauna across multiple continents, something that forced human populations to abandon coastal settlements and migrate inland or drown. Something that might have destroyed civilizations we know nothing about, because all the evidence is now under hundreds of feet of seawater. The question isn't whether this happened. The evidence is overwhelming. The question is what triggered it. What could cause ice sheets miles thick, covering millions of square miles, to melt so rapidly that sea levels rose 400 feet. And not just melt slowly over tens of thousands of years, but catastrophically in pulses, in flooding events so massive they created scars on the landscape we can still see today. This is the story we're going to explore. The story of what Earth was like during the last ice age. The story of the younger Dryas, the mysterious cold snap that interrupted the warming. The story of the great melt and the floods that followed. The story written in ancient myths, geological evidence, and the drowned landscapes that lie beneath our modern oceans. It's a story about catastrophe, about survival, about how a planetary disaster 12,000 years ago might have shaped everything that came after. The rise of agriculture, the birth of civilization, the myths and memories that every culture carries about a time when the world drowned. And it's a story that's more relevant today than ever. Because we live on a planet with ice sheets, ice that could melt, sea levels that could rise, and billions of people living on coastlines that might not always be coastlines. But we're getting ahead of ourselves. First, we need to go back, way back, to understand what the world looked like before the flood, to see the Ice Age Earth as our ancestors saw it, frozen, harsh, and about to change forever. Let's travel back 20,000 years, not in a time machine, but in your imagination. Close your eyes for a moment and try to picture Earth during the last glacial maximum, the absolute peak of the most recent ice age. What do you see? If you're imagining a slightly colder version of today's world with some extra snow, you're not even close. The planet 20,000 years ago was almost unrecognizable compared to the world you know. This wasn't just winter that lasted a little longer. This was a fundamentally different Earth, a world where ice had conquered entire continents and held them in a frozen grip that had lasted for thousands of years. Start with North America. Today, you can drive from New York to Chicago without seeing anything more threatening than a snowstorm. Back then, that entire route would have been buried under ice. Not a few feet of ice, not even a few dozen feet. We're talking about ice sheets over 2 miles thick in places. 2 miles. Imagine stacking 7 Empire State Buildings on top of each other, and you're still not at the top of the ice. This wasn't a glacier you could walk around. This was the Laurentide ice sheet, a continent-sized mass of ice that covered everything from the Arctic Ocean down to where New York City stands today. It extended west past the Great Lakes, covering nearly all of Canada and much of the northern United States. The weight of all that ice was so immense it actually pressed the Earth's crust down, deforming the solid rock beneath like pushing your thumb into clay. Europe wasn't any better. The Scandinavian ice sheet covered all of Norway, Sweden, Finland, and extended south into Germany and east into Russia. Britain and Ireland were buried under the British-Irish ice sheet. If you wanted to visit London 20,000 years ago, you'd need to dig through a mile of ice first. Good luck with that. Asia had its own ice sheets covering Siberia. South America's southern regions were glaciated. Even mountain ranges near the equator that are green and temperate today were capped with massive glaciers that extended thousands of feet lower than modern ice fields. But here's what's really mind-blowing. All that ice had to come from somewhere. Water doesn't just materialize out of nothing. Every drop of moisture locked up in those continental ice sheets had been pulled from the oceans through tens of thousands of years of snowfall that never melted. Year after year, century after century, millennium after millennium, water evaporated from the seas, fell as snow on the ice sheets, and stayed there, frozen, locked away, removed from the water cycle. The numbers are almost incomprehensible. At the peak of the last glacial maximum, about 50 million cubic miles of water was trapped in ice. That's roughly 50 times the volume of all the Great Lakes combined. To put it another way, if you could somehow melt all of today's remaining ice sheets and glaciers, global sea levels would rise about 230 feet. During the Ice Age, sea levels were 400 feet lower than they are today. 400 feet. Think about what that means. The ocean shorelines weren't just a bit farther out, they were fundamentally different. Entire sections of continental shelf that are underwater today were dry land, habitable territory where people lived, hunted, built communities, and created cultures that are now lost beneath hundreds of feet of seawater. The North Sea, that body of water between Britain and Europe, didn't exist. It was a vast plain called Doggerland, a rich lowland ecosystem with rivers, forests and grasslands. Britain wasn't an island. You could walk from London to Paris without getting your feet wet. The English Channel was a river valley. Archaeological evidence suggests it was one of the largest river systems in Europe, fed by the Thames and the Rhine as they flowed north across the exposed plain before finally reaching the Atlantic far beyond where the modern coastline stands. In Southeast Asia, the entire region looked completely different. The islands of Indonesia, Malaysia, and the Philippines weren't separated by deep ocean channels. They were connected by the Sunda Shelf, a massive landmass that extended hundreds of miles beyond modern coastlines. You could walk from Malaysia to Borneo, from Sumatra to Java. The South China Sea was largely dry land. The same pattern repeated around the world. The Persian Gulf didn't exist as a body of water, it was a river valley. The coastlines of Africa, Australia and the Americas extended miles, sometimes dozens of miles, beyond their present positions. And all of that exposed land, all of those now submerged territories, they weren't barren desert. They were some of the most productive, resource-rich environments on the planet. Think about it from an ecological perspective. Continental shelves are shallow regions where nutrients concentrate. Even today, when they're underwater, they're incredibly productive marine ecosystems. When they were exposed during the Ice Age, they would have been even richer. River valleys cutting through the plains would have created diverse habitats. Coastal forests would have thrived in the moderate climates. Grasslands would have supported massive herds of animals. This was prime real estate, and humans were living there in large numbers. But we're getting ahead of ourselves. Let's talk about the land itself, the parts that weren't underwater or buried in ice. Because the Ice Age Earth wasn't just cold, it was connected in ways that seem impossible today. Between Siberia and Alaska, where the Bering Strait separates two continents with 55 miles of frigid ocean, there was no water at all. Beringia, a landmass over 1,000 miles wide, connected Asia and North America in a continuous grassland ecosystem. Herds of mammoths, bison, and horses migrated freely between continents, and humans followed them, walking from Asia into the Americas across what is now one of the most forbidding ocean passages on Earth. These land bridges weren't rare exceptions, they were everywhere. Animals that are separated by oceans today were part of continuous populations. Genetic evidence shows that species now isolated on different landmasses were freely interbreeding just 15,000 years ago. The planet's geography was fundamentally different, and so was its biology. And the animals. My God, the animals! If you could somehow be transported back to Ice Age, Earth with the guarantee of safety, just to observe, you would see creatures that seem like they belong in fantasy novels, not natural history. Woolly mammoths, obviously, But these weren't rare or isolated. They were abundant, forming herds that numbered in the thousands, migrating across the grasslands of Europe, Asia, and North America in seasonal patterns that had persisted for hundreds of thousands of years. But mammoths were just the beginning. There were woolly rhinoceroses, massive creatures covered in thick fur, with horns that could reach 3 feet long. Giant ground sloths in the Americas, some species weighing over 3 tons, as large as modern elephants but more heavily built. Glyptodons, armadillo-like creatures the size of small cars, with spiked tails that could shatter bone. Saber-toothed cats, not just the famous Smilodon, but multiple species of large predators with elongated canines designed for bringing down megafauna. In Australia there were marsupial lions, diprotodonts that looked like giant wombats weighing over 2 tons, and flightless birds that stood 10 feet tall. Europe had cave bears that dwarfed modern grizzlies, and giant elk with antlers spanning 12 feet from tip to tip. The oceans were home to whales and sharks even larger than today's species, adapted to the colder, more productive waters of the Ice Age seas. This wasn't a world diminished by cold. It was a world transformed, where the dry climate and extensive grasslands supported animal biomasses that might have exceeded even Africa's modern Serengeti. The key was productivity. Yes, it was cold, but it was also stable. The Ice Age climate had persisted, with relatively minor variations, for over 80,000 years. That's not a blip in geological time. That's enough for entire ecosystems to adapt, specialize, and thrive. Plant communities had evolved to maximize growth during short summers. Animals had developed migratory patterns that let them exploit seasonal abundance across vast territories. Predators had refined hunting strategies to take down the largest land animals in Earth's history. And humans, modern humans who had evolved in Africa and spread across the planet during the Ice Age, had become master hunters capable of bringing down mammoths with nothing more than spears, coordination, and accumulated knowledge passed down through generations. These humans were living along those now submerged coastlines in numbers that would surprise most people. We think of Ice Age humans as rare, scattered populations barely hanging on to survival. But genetic and archaeological evidence suggests otherwise. Ice Age populations might have been quite large in favourable areas, especially along coastlines where marine resources supplemented terrestrial hunting. The problem is, we can't easily study these populations because their sites are underwater now. When sea levels rose at the end of the Ice Age, they didn't just flood empty beaches, they drowned living communities, archaeological sites, entire landscapes of human habitation. The rising water erased evidence of cultures that might have been quite sophisticated, leaving us with only the inland sites, which might not represent the full picture of Ice Age human achievement. But we can make some inferences. Sites that have been found suggest humans were creating art, developing complex technologies, maintaining trade networks that spanned hundreds of miles. They were processing plant foods in ways that required detailed ecological knowledge. They were building structures, not just caves and simple shelters, but planned constructions that required coordination and effort. Some sites show evidence of astronomical observations, suggesting these people were tracking seasonal changes with precision. They were also incredibly tough. Living in an Ice Age world required skills that most modern humans couldn't replicate if our lives depended on it. They could read landscapes, predict animal movements, navigate by stars and landmarks across territories that would kill you in days if you didn't know what you were doing. They could make fire in any conditions, create clothing that could keep them alive at 40 below, and survive injuries that would be fatal without modern medicine. And they did this in a world that, for all its abundance, was also incredibly dangerous. Not just from the cold or the megafauna, though a mammoth could certainly kill you if you made a mistake. The danger came from the fundamental instability lurking beneath the apparent stability. Because here's what nobody living 20,000 years ago could have known. The Ice Age world was essentially a loaded gun. All those massive ice sheets, all that frozen water, it wasn't just sitting there inert. It was part of a complex system that included not just the ice itself, but the land beneath it, the climate around it, and most critically, the water trapped behind it. As the ice sheets advanced and retreated over thousands of years, they acted like massive bulldozers, scraping and carving the landscape. In some places, this created natural dams, ice barriers that held back enormous quantities of meltwater. These weren't small ponds. They were inland seas, glacial lakes that contained more water than all of North America's modern Great Lakes combined. The largest was Glacial Lake Agassiz, located in what is now central Canada and the northern United States. At its maximum extent, it covered over 170,000 square miles and held more water than all of today's lakes combined. All of that water was held in place by ice dams, frozen barriers that were strong as long as they stayed cold, but potentially catastrophic if they melted. And there were other glacial lakes scattered around the ice sheet's margins. Glacial Lake Missoula in what is now Montana, Glacial Lake Columbia in British Columbia, dozens of smaller lakes across Europe and Asia. Each one was a reservoir of potential energy, millions of cubic miles of water held back by nothing more than ice and rock. The people living downstream from these ice dams had no idea they existed. How could they? The lakes were hundreds of miles away, beyond the ice, in regions no human had seen for thousands of years. The Ice Age world had been stable for so long that nobody could imagine it changing. The cold was just how the world was. The ice sheets were permanent features of the landscape, as unchanging as mountains. But change was coming. Subtle at first, barely noticeable over a human lifetime, but building inexorably toward a catastrophic transformation. The Earth's orbital cycles, those same Milankovitch variations that had triggered the Ice Age in the first place, were shifting again. Solar radiation reaching the northern hemisphere was gradually increasing. Summers were getting imperceptibly warmer. Ice that had been accumulating for 80,000 years was about to start melting. And when it did, when those ice dams finally failed and those glacial lakes found their way to the sea, the stable Ice Age world was going to end in a catastrophe unlike anything humans had ever witnessed. The flood that would reshape the planet was coming, but nobody saw it coming. How could they? The world had been frozen for longer than human memory, longer than human legend. The ice seemed eternal, and that's exactly what made what happened next so devastating. But here's the thing about the end of the Ice Age. It didn't just end. It stuttered, it stumbled, and then it hit the emergency brake one last time in the most dramatic way possible. Just when the planet seemed ready to finally shake off the ice and move into a warmer, more stable climate, everything went sideways. This is the story of the younger Dryas, the big freeze that nobody saw coming, and the pressure cooker it created that would eventually unleash the greatest flood in human history. Picture this. It's 13,000 years ago, and if you're a human living anywhere in the Northern Hemisphere, life has been getting better for the past 2,000 years. Not easy, not comfortable, but definitely better. The glaciers that had covered vast sections of North America and Europe for tens of thousands of years are finally retreating. The ice sheets that stretch from the Arctic to what would become New York City, all the way across to London and Berlin, they're melting. Slowly at first, then faster as the planet warms. Summer temperatures are rising. Growing seasons are lengthening. The tundra that had dominated the landscape is being replaced by grasslands and forests. Animals are following the changing vegetation north. Herds of mammoth, caribou and bison that had been compressed into narrow bands of habitable territory during the glacial maximum are now spreading out, finding new grazing lands. And humans, your ancestors, are following them. They're expanding into territories that have been locked under ice for millennia. They're developing new hunting strategies for this changing world. They're probably thinking the worst is over, that they've survived the Ice Age, and now it's just a matter of adapting to an increasingly hospitable planet. Then, 12,900 years ago, everything changed. Within a human lifetime, maybe faster, the warming stopped. Not gradually, not with warning signs that people could prepare for, but suddenly, like someone flipped a switch. Temperatures plummeted. Summer temperatures in the northern hemisphere dropped by as much as 15 degrees Celsius in some regions. That's 27 degrees Fahrenheit, in case you're wondering, and it happened in what geological records suggest might have been as little as a decade. Imagine living through that. One generation experiences increasingly mild summers and shorter winters. The next generation watches the forests die back, the grasslands turn to tundra, and the ice begin advancing again. The glaciers that had been retreating for 2,000 years suddenly stabilized, and in many places started growing again. This wasn't supposed to happen. The orbital cycles that drive ice ages, the Milankovitch cycles that control how much solar radiation different parts of Earth receive, they were still pointing toward warming. The planet should have continued getting warmer. Instead, it went into the freezer for what would turn out to be 1,300 years. Scientists call this period the Younger Dryas, named after a small Arctic flower called Dryas octopetala that suddenly appears in European pollen records from this time. This flower is a tundra specialist, a plant that thrives in the kind of cold, harsh conditions that have been disappearing from Europe for centuries. Its sudden reappearance in the geological record is like a message from the past. The cold came back, and it came back hard. But here's the mystery that's driven scientists crazy for decades. What caused it? How do you suddenly freeze a planet that's in the middle of warming up? You can't just turn down the sun. The orbital cycles don't change that fast. So, what happened? The theories have been flying for years, and to be honest, we still don't have complete consensus, but we've got some pretty compelling ideas. Theory 1, the meteor impact hypothesis. In 2007, a group of researchers proposed that the Younger Dryas was triggered by a cosmic impact, either a comet or asteroid that exploded over North America around 12,900 years ago. The idea is that the impact threw enormous amounts of debris into the atmosphere, blocking sunlight and rapidly cooling the planet. It's the same mechanism that killed the dinosaurs 66 million years ago, just on a smaller scale. The evidence? There's a layer in the geological record from exactly this time period that contains unusual concentrations of materials that shouldn't be there. Nanodiamonds, which form under extreme pressure and temperature, magnetic spherules, tiny balls of melted rock, platinum group elements at concentrations way higher than normal background levels, soot and carbon indicating massive wildfires. Proponents argue this is the signature of an impact, debris from a cosmic collision scattered across the northern hemisphere. Critics say maybe, but the evidence isn't definitive enough, and some of these materials can be created by other processes, like volcanic eruptions or even large-scale wildfires without any extraterrestrial involvement. Theory 2. Massive volcanic eruptions. Volcanoes pump sulfur dioxide and ash into the atmosphere, creating a cooling effect that can last years or even decades after a major eruption. Several large volcanic events happened around this time, and it's possible one or more of them triggered a feedback loop that maintained cooling for centuries. The problem with this theory is we haven't found geological evidence of eruptions large enough to cause 1,300 years of cooling. The volcanic deposits from this period aren't dramatically larger than those from other times that didn't trigger Ice Age conditions. So while volcanism might have played a contributing role, it probably wasn't the primary driver. Which brings us to Theory 3, the freshwater pulse hypothesis, and this is where things get really interesting because this theory directly connects to the flood that would come later. Here's how it works. As the Ice Age was ending, enormous amounts of meltwater from retreating glaciers were collecting in huge lakes. We're not talking about normal lakes. We're talking about inland seas the size of modern countries. The largest was Glacial Lake Agassiz, a monstrous body of water that covered much of central North America. At its maximum extent, it contained more water than all current North American Great Lakes combined. This lake was held back by ice dams, walls of glacial ice hundreds of feet high. As long as those dams held, the water just kept accumulating, getting deeper and deeper as more ice melted. But ice dams are inherently unstable. They float if the water gets deep enough. They crack. They collapse. The freshwater pulse hypothesis says that around 12,900 years ago, one of these ice dams failed catastrophically. Billions of gallons of fresh water from Glacial Lake Agassiz suddenly burst through its ice dam and flooded into the North Atlantic Ocean. Now here's why that matters. The ocean circulation system that moderates Earth's climate, what scientists call the Atlantic Meridional Overturning Circulation, or AMOC, it depends on density differences in seawater. Cold, salty water in the North Atlantic sinks and flows south along the ocean floor. Warm water from the tropics flows north along the surface to replace it. This conveyor belt of water carries enormous amounts of heat from the equator to the North Atlantic, which is why Europe is so much warmer than other places at the same latitude. Without the Gulf Stream, which is part of this circulation system, London would have the climate of northern Canada. But this circulation system has an off switch. Fresh water is less dense than salt water. If you suddenly dump enough fresh water into the North Atlantic, it can form a layer on the surface that prevents the salty water from sinking. The conveyor belt stops, heat stops flowing north, and the entire northern hemisphere, especially the regions around the North Atlantic, suddenly gets much, much colder. The geological evidence strongly supports this scenario. There are layers in North Atlantic sediment cores from exactly this time period that show a sudden influx of fresh water. The isotopic signatures match glacial meltwater from North America. The timing lines up perfectly with the start of the Younger Dryas. Most climate scientists now think this freshwater pulse was the primary trigger, though meteor impact and volcanic activity might have played contributing roles. But whatever caused it, the effect was devastating for the humans living through it. Your ancestors, who had been adapting to a warming world, suddenly had to deal with Ice Age conditions returning. The animals they hunted began dying off or migrating away from regions that were once again becoming uninhabitable. The plants they gathered, which had been expanding their range northward, suddenly stopped growing in areas where they'd been reliable food sources for generations. This wasn't just inconvenient. This was an extinction-level event for some human populations. groups that had specialized in hunting large Ice Age mammals. The mammoth hunters who had developed sophisticated strategies for taking down these enormous animals, they were suddenly facing prey populations that were under massive stress. Starvation was a real threat. Archaeological evidence from this period shows declining human populations in many regions, abandoned settlement sites, and signs of nutritional stress in human remains that do survive. But here's what makes the Younger Dryas particularly important for our story. It didn't just make things cold again. It reset the entire melting process. All that ice that had been melting for 2,000 years, it stopped melting. The glaciers stabilized. In some places they began advancing again, though not to their previous maximum extent, and the ice dams that had been weakening as temperatures warmed, they got a reprieve. They stabilized too, reinforced by new ice and colder temperatures. This created what would turn out to be a massive pressure cooker effect. Because even though surface temperatures dropped, the underlying warming trend driven by Earth's orbital cycles was still there. The planet was still receiving more solar radiation than during the glacial maximum. Ice was still melting, just more slowly, and that meltwater had to go somewhere. With the North Atlantic circulation shut down, and temperatures hovering just above glacial maximum levels, the meltwater couldn't drain away as fast as it might have otherwise. So it accumulated. Glacial lakes that had been draining slowly began filling up again. Ice dams that had been on the verge of failure got stronger, able to hold back even more water. The ice sheets themselves became increasingly unstable. They weren't growing thicker everywhere like during the glacial maximum. Instead, they were maintaining massive volumes of ice that was increasingly saturated with meltwater at the bottom, where pressure and friction create heat even in sub-freezing surface conditions. Think of it like this. You've got a dam holding back a reservoir. The dam develops cracks, starts leaking, the water level begins dropping, then suddenly you get a cold snap that freezes those cracks shut. The dam can hold again, but the water behind it keeps rising because streams are still flowing into the reservoir. Now the dam is holding back more water than ever, and it's still damaged from the previous leaking. It's stronger than it was when it was about to fail, but it's under more pressure than it's ever been designed to withstand. That's what the Younger Dryas did to the glacial system. It created a temporary reprieve that allowed ice structures to stabilize while water and energy continued building up behind them. For 1,300 years, this pressure kept building. Glacial Lake Agassiz, which had partially drained during the initial warming period, filled back up to unprecedented levels. Other glacial lakes across North America and Europe did the same. The ice sheets covering Greenland, northern Canada, and Scandinavia maintained enormous volumes of ice while their bases became increasingly unstable. Meltwater channels carved deeper and deeper into the ice from below, and humans living near these glacial features had no idea they were living next to the largest time bombs in natural history. Then, around 11,600 years ago, everything changed again. The reasons are still debated, but the most likely explanation is that the freshwater pulse that had shut down the Atlantic circulation finally dispersed. Either it mixed with salt water enough to restore density gradients, or it spread out enough that salty water could sink again in other regions. Whatever the specific mechanism, the amok turned back on. Heat began flowing north again, and temperatures rose even faster than they dropped 1,300 years earlier. Some geological records suggest the warming at the end of the Younger Dryas happened in less than a decade. 1 year you're dealing with Ice Age conditions. 10 years later you're living in what's essentially a modern climate. The speed of this transition is almost incomprehensible. The glaciers that had been stable for over a millennium suddenly found themselves in a world where summer temperatures were 10, 15, even 20 degrees warmer than they'd been for centuries. And remember all that stored water, all those ice dams that had been holding back inland seas for 1,300 years, all the meltwater channels carved into the bases of ice sheets, all the pressure that had been building while the climate was locked in its cold snap. It all let go at once. The ice dams that had been reinforced during the Younger Dryas were still structurally compromised from the warming period before. They'd been patched, not rebuilt. Now they were facing warmer temperatures than ever, while holding back more water than they were originally designed to contain. The result was catastrophic. Within years, maybe even months after the Younger Dryas ended, ice dams across the northern hemisphere began failing, not one at a time, but in cascades. One dam fails, the water behind it surges out and undermines or overwhelms the next dam downstream. That dam fails, releasing even more water. Each failure makes the next one more likely. Glacial Lake Agassiz, which had been filling for 1,300 years, suddenly had no ice dam holding it back. Billions of gallons of water began flowing toward the sea. But this wasn't a gradual release. This was a flood that would make biblical deluge look like a spring shower. And it wasn't just North America. Similar processes were happening in Europe, Asia, anywhere you had glacial ice interacting with accumulated meltwater. The Younger Dryas had set the stage. Now the curtain was about to rise on the greatest flood in human history. Everything that happened next, the stories that would become flood myths across dozens of cultures, the geological scars that would puzzle scientists for centuries, the transformation of human civilization from scattered hunter-gatherer bands into settled agricultural societies, all of it traces back to this moment when the big freeze finally ended and the ice walls broke. Then it happened. The moment that would reshape continents and end the Ice Age forever. Around 11,700 years ago, something triggered a climate shift so sudden and so dramatic that it shows up in ice cores as a sharp line, not a gradual transition, not a slow warming over centuries, a geological instant. Within just a few decades, maybe even a few years, global temperature shot up by 10 to 15 degrees Fahrenheit in some regions. The Younger Dryas, that final cold snap that had gripped the northern hemisphere for over 1,000 years, simply ended. Like someone flipped a switch and the freezer turned off. Scientists still debate exactly what triggered this abrupt warming. Some think changes in ocean circulation patterns suddenly kick the climate system into a new state. Others point to shifts in atmospheric circulation or variations in solar radiation. There's even a controversial theory involving a comet impact that destabilized the ice sheets. But whatever the trigger, the effect was catastrophic, because the warming didn't just melt ice gradually. It destroyed the structural integrity of ice dams that had been holding back entire inland seas. Picture this. For thousands of years, massive ice sheets up to 2 miles thick had been damming rivers across North America. These weren't normal rivers. These were continent-draining systems fed by melting glaciers. And behind the ice dams, water had been accumulating for millennia. Glacial Lake Agassiz alone, trapped behind ice walls in what's now Manitoba and Ontario, contained more water than all the modern Great Lakes combined. Some estimates put its volume at over 440,000 cubic miles of fresh water. That's enough water to submerge the entire United States under 3 feet of liquid. The ice dams holding this water back were hundreds of feet thick. Massive structures that had seemed permanent, eternal, as unchangeable as mountains. But ice has a weakness. It melts. And when the sudden warming hit, those ice dams began to fail. Not slowly, not gradually, catastrophically. Here's the thing about ice dam failures. They don't happen like you might imagine. It's not a gentle overflow where water starts trickling over the top and slowly erodes the dam away. It's structural collapse. Water is heavy. A cubic foot weighs about 62 pounds. When you've got hundreds of cubic miles of water pressing against an ice dam, that's unimaginable pressure. Millions of tons per square foot. As the warming progressed, the ice began to soften. Cracks formed. Water started seeping through weak points, creating channels that widened as warmer water flowed through them, melting the ice from within. The dams were being undermined from below and eroded from above simultaneously. Then one day, somewhere along the southern edge of glacial Lake Agassiz, a section of ice dam failed. Maybe it started with a crack, a sudden shift as warming weakened a critical support structure. Maybe it was a collapse of the underlying sediment that the ice had been anchored to. We'll never know the exact mechanism, but we know what happened next because the evidence is carved into the landscape in letters 1,000 feet high. The water didn't just flow, it exploded. Imagine the largest dam failure in modern history, then multiply it by 1,000, by 10,000. When that ice wall broke, billions of gallons of water per second blasted through the gap. The initial surge would have been a wall of water hundreds of feet high, moving at speeds approaching 80 miles per hour. Nothing in its path survived. Trees were ripped from the ground like weeds. Boulders the size of houses were picked up and carried for miles. Entire hillsides were scoured down to bedrock in minutes. This was the first of what geologists call the Missoula floods, though that name is misleading because it suggests a single location. The reality was far more complex and catastrophic. As the ice dams failed across North America, multiple outbursts. Floods occurred, some simultaneously, some in rapid succession. Each flood released enough water to raise global sea levels by measurable amounts. But the most dramatic evidence comes from the Pacific Northwest. The channeled scablands of eastern Washington state preserve the scars of these megafloods in almost perfect detail. If you fly over the region today, you'll see something that looks like Mars. Massive channels carved into solid basalt, some over 900 feet deep and 50 miles wide. Islands of harder rock standing like monuments in the middle of dry valleys. Giant ripples in the landscape, each one hundreds of feet high, created by floodwaters carrying rocks and sediment in waves that would dwarf any tsunami in recorded history. J. Harlan Bretz, the geologist who first proposed catastrophic flooding as the explanation for these features, was ridiculed for decades. The geological establishment couldn't accept that landscapes could be carved so quickly. Uniformitarianism, the principle that geological processes happen gradually over immense time periods, was dogma. Catastrophism had been rejected by mainstream geology. But Bretz was right. The evidence was undeniable once people looked at it without preconceptions. The scablands weren't created over millions of years. They were carved in days, maybe hours, by floods of such magnitude that they redefined what was considered possible. The floods created temporary waterfalls that would have made Niagara look like a garden fountain. Dry Falls in Washington state preserves the location of one such cataract. At 3.5 miles wide and 400 feet high, it's more than twice the width of Niagara. During the floods, water was pouring over this cliff at rates estimated at 10 times the flow of all current rivers on Earth combined. The roar would have been audible hundreds of miles away. The mist would have created permanent rainbows visible from space if there had been anyone in space to see them. But the Pacific Northwest floods were just the beginning. Lake Agassiz had multiple outlets, and as different ice dams failed at different times, the water found new paths to the sea. Some floods roared south down the Mississippi River Valley. Others burst northeast, pouring into the North Atlantic through the St. Lawrence River Valley. Each outburst was a civilization-ending event. If there had been cities in the flood paths, they would have been obliterated, swept away so completely that no trace would remain. And there were people there. Paleo-Indian populations had spread across North America by this time. Small groups, maybe a few thousand individuals total, but they were there, hunting mammoths and giant bison, fishing in rivers that would soon become raging torrents of destruction. The floods would have appeared with little warning, maybe a distant rumbling, like thunder that didn't stop. Maybe a sudden rise in river levels that kept rising and rising impossibly past any flood, stage anyone had ever seen. Then the wall of water arrives and everything ends. We have no written records, obviously, no direct evidence of human casualties. But it strains credibility to think that nobody was caught in these megafloods. Entire populations could have been wiped out in minutes, their campsites and hunting grounds buried under hundreds of feet of flood deposits or scoured away entirely. The genetic bottleneck around this period in some Native American populations might reflect these catastrophic losses. But here's where it gets even worse. The floods didn't just carve landscapes and kill anyone unlucky enough to be in their path. They triggered a domino effect that would remake entire continents. Because all that fresh water had to go somewhere, and where it went had consequences that cascaded through the climate system like falling dominoes. When billions of tons of fresh water from Lake Agassiz poured into the North Atlantic, it didn't just raise sea levels, it disrupted the ocean circulation patterns that regulate global climate. The North Atlantic Drift, the warm current that keeps Europe relatively mild despite its northern latitude, depends on a delicate balance of temperature and salinity. Warm, salty water flows north on the surface, cools, becomes dense, and sinks, creating a conveyor belt of circulation that transports heat from the tropics to the polar regions. Dump enough fresh water into this system and it breaks. Fresh water is less dense than salt water. It stays on the surface, preventing the normal sinking that drives circulation. The conveyor belt slows or stops entirely. Heat transport shuts down. And suddenly, Europe, which should be frozen tundra given its latitude, loses the warming influence that makes it habitable. Some scientists think this disruption of ocean circulation is what triggered the younger Dryas in the first place, an earlier episode of ice dam failure that sent enough meltwater into the North Atlantic to shut down the circulation system, plunging the northern hemisphere back into near ice age conditions. Then, when the ice sheets finally collapsed for good 11,700 years ago, the massive influx of fresh water triggered another circulation crisis. But this time the warming momentum was too strong to reverse. Meanwhile, in Eurasia, similar dramas were playing out. The Fennoscandian ice sheet, covering what's now Scandinavia and much of northern Europe, was disintegrating. Ice dams holding back glacial lakes in Russia and Siberia were failing. Each failure sent new pulses of meltwater cascading into the Arctic Ocean and the North Atlantic. The Baltic Sea basin, which had been an ice-covered depression, transformed into a freshwater lake, then a brackish sea as rising ocean waters broke through the Danish Straits. The speed of these changes is hard to comprehend. We're talking about landscape transformations that would normally take tens of thousands of years happening, in decades. Coastlines that had been stable for millennia were suddenly submerged under rising seas. River valleys that had been dry highlands became drowned estuaries. Islands appeared and disappeared as water levels fluctuated wildly. And it wasn't just one pulse of meltwater. The geological evidence shows multiple episodes of catastrophic flooding over a period of several thousand years. As temperatures rose, ice sheets that had seemed stable would suddenly collapse, releasing new floods. Lake Agassiz itself drained and refilled multiple times as different ice dams failed and reformed. Each drainage event was a potential civilization killer. Each refilling period gave the false impression of stability before the next catastrophe. The largest single drainage event recorded in sediment cores from the North Atlantic and Hudson Bay seems to have occurred around 8,470 years ago. In possibly a single year, maybe even a single season, Lake Agassiz catastrophically drained through Hudson Bay into the North Atlantic. The estimated volume, over 40,000 cubic miles of water, enough to raise global sea levels by more than 3 feet almost overnight. The flood carved channels through bedrock that are still visible today. It redistributed sediment over thousands of square miles. It created the modern geography of Hudson Bay. But perhaps the most haunting evidence of these megafloods comes from underwater archaeology in the Pacific Northwest. At the bottom of Puget Sound and along the drowned coastlines of British Columbia, researchers have found trees still rooted in their original growth positions, preserved in the cold, oxygen-poor water. These aren't fossil trees, they're actual wood, still intact after 12,000 years, and they're in growth positions that show they were living trees that were suddenly and catastrophically drowned when sea levels rose too fast for the trees to adjust. Carbon dating of these submerged forests gives us precise dates for the flooding events. Rings in the waterlogged wood tell us exactly when the trees stopped growing, down to the season and sometimes the month. This forensic precision reveals a pattern of rapid sea level rise, punctuated by even more rapid pulses associated with ice dam failures. The floods weren't steady. They came in waves, each wave raising sea levels by feet or even tens of feet in single events. Think about what that means for anyone living on the coast. You're a fisher, part of a community that's been occupying the same beach for generations. Your ancestors' graves are up on the bluff. Your boat is pulled up on familiar sand. The tide comes in and goes out with comforting regularity. Then, one day, the tide comes in and doesn't go out. The next day, it rises further. Within a week, your village is underwater. Within a month, your entire territory has become seafloor. The landscape of your entire world has been erased, drowned, transformed into an alien environment where nothing is familiar anymore. This wasn't just happening in one place, it was global. As ice sheets collapsed across North America, Scandinavia and Siberia, as mountain glaciers disintegrated from the Alps to the Andes, as the Antarctic ice shelves broke apart and slid into the Southern Ocean, sea levels rose worldwide. Coastlines that had been exposed during the Ice Age, when so much water was locked up in ice that sea levels were 400 feet lower than today, these coastlines disappeared beneath the waves. The Bering Land Bridge connecting Asia and North America flooded, cutting off migration routes that humans had used for thousands of years. The English Channel opened, separating Britain from continental Europe. The Persian Gulf filled with water, transforming a river valley into a sea. The Black Sea expanded dramatically when rising Mediterranean waters broke through the Bosporus Strait. Each of these flooding events was experienced by real people as the end of their world. The landscapes they knew, the territories their ancestors had occupied for hundreds or thousands of years, were simply erased, and the floods themselves, the actual catastrophic releases of water from failing ice dams, those would have been experiences beyond anything in modern human history. The closest analogue we have are accounts from rare ice dam failures in places like Iceland, where glacial lakes occasionally burst through ice barriers in events called Jukullaups. Even these relatively small events, releasing maybe a few cubic miles of water, are terrifying enough that they've entered Icelandic folklore as supernatural catastrophes. Now multiply that by 1,000. Imagine not millions, but billions of tons of water exploding from behind ice walls, carving new valleys, creating temporary seas, reshaping entire regions in hours or days. Imagine the sound, the ground-shaking roar of moving water, carrying icebergs the size of buildings, boulders weighing hundreds of tons, entire forests ripped from the earth. Imagine the mist, the spray thrown up by falling water creating clouds that would have covered the sky for days. Imagine the aftermath, a landscape scoured down to bedrock, alien and unrecognizable. This was the Great Melt. Not a gentle thawing, but a violent, catastrophic transformation of the planet's surface. A series of disasters that would have seemed apocalyptic to anyone who witnessed them. And people did witness them. They survived them, barely, and passed down the memories to their children, who passed them to their children, until those memories became myths. Stories of floods that covered the world, of waters that rose until they reached the mountains, of times when the gods decided to wash the earth clean and start over. But that was still to come. For now, in the immediate aftermath of the ice dam failures, the survivors faced a new challenge. Because all that meltwater didn't just carve valleys and create floods, it raised the oceans, and when the oceans rose, an entire world drowned beneath the waves. But here's what nobody tells you about the end of an ice age. It doesn't happen all at once. There's no single moment when everything changes. Instead, it's a slow-motion catastrophe that unfolds over thousands of years, generation after generation watching the world they know gradually disappear beneath the waves. 400 feet. That's how much the oceans rose between roughly 15,000 and 7,000 years ago. 400 feet of vertical sea level change. To put that in perspective, that's taller than a 30-story building. Imagine standing on a beach and knowing that within a few thousand years, everything for miles inland, perhaps hundreds of miles, will be underwater. Now, 400 feet spread across 8,000 years might not sound dramatic. That's what? About 6 inches per decade? Your grandparents wouldn't notice much change in their lifetime. Maybe the high tide line moves a bit. Maybe that peninsula becomes an island. Nothing catastrophic, right? Wrong. Because sea level rise doesn't happen evenly. It comes in pulses. Sometimes the water advances slowly for centuries, then suddenly something breaks. An ice dam fails. A glacial lake the size of a small sea drains in a matter of weeks. The ocean surges forward, swallowing coastlines that have been stable for generations. Then it stabilizes again for a while before the next pulse. And here's the thing that makes this truly terrifying. During the Ice Age, when sea levels were 400 feet lower, the world map looked completely different from what we know today. All that water locked up in ice sheets meant vast areas of continental shelf were exposed. Not just narrow strips of beach, but entire landscapes, river valleys, forests, grasslands, some of the most productive territories on Earth. And that's exactly where humans lived. Because of course they did. Evolution doesn't make stupid choices. The coastal zones were paradise compared to the continental interiors. Milder temperatures moderated by the ocean, access to both marine and terrestrial food sources, rivers that provided fresh water and transportation routes, natural harbours that offered protection from storms. These weren't marginal territories. These were the prime real estate of the Ice Age world. Archaeological evidence suggests that many of the most sophisticated human cultures of the late Ice Age were coastal peoples. They had developed maritime technologies, sophisticated fishing techniques, probably some of the first systematic seafaring and boat building. They were exploiting a three-dimensional environment, land, sea, and the productive zone where the two met. Population densities in these coastal zones might have been much higher than in the continental interiors, and all of it was about to drown. Let's start with one of the most dramatic examples, the Black Sea. Today it's connected to the Mediterranean through the narrow Bosporus Strait. But during the Ice Age, it wasn't connected at all. Sea levels were so low that the Bosporus was dry land. The Black Sea was actually a giant freshwater lake, fed by rivers draining the steppes and forests of Eastern Europe and Western Asia. Its surface sat about 400 feet lower than the Mediterranean. Around the margins of this freshwater lake, human populations had settled. The shores were rich with resources: freshwater fish, waterfowl, forests full of game, fertile river valleys perfect for early agriculture. For thousands of years after the ice began retreating, these communities thrived. The lake level fluctuated with rainfall and runoff, but it remained stable, a closed basin with no connection to the rising oceans beyond, until around 7,600 years ago. That's when the Mediterranean, swollen with meltwater from collapsing ice sheets, finally reached a critical threshold. The water level rose high enough to begin spilling over the Bosporus land bridge. At first it might have been a trickle, a small stream flowing from the Mediterranean into the Black Sea basin. But erosion works fast when you have the entire Mediterranean Sea pushing behind it. Within years, maybe even months, that trickle became a torrent. Geological evidence suggests water was pouring through the Bosporus at a rate 200 times greater than Niagara Falls. 200 times. The roar of that much water would have been audible for hundreds of miles. The spray would have created permanent rainbows in the sunlight and persistent fog at night. The Black Sea basin was filling at a rate of about 6 inches per day. That might not sound like much, but think about what it means for the people living on those shores. You go to sleep, and when you wake up, the waterline has moved inland by several feet, every day, without stopping, for months. This wasn't a flood that came and went. This was the permanent drowning of an entire world. Villages that had stood for generations vanished beneath the advancing waves. Forests drowned. River valleys became bays. Within a year, the entire character of the Black Sea had transformed from a freshwater lake to a saltwater sea. Everything living in those waters died as the salt water mixed with fresh. Archaeological sites that might have told us about these coastal peoples are now under hundreds of feet of water, scattered across a drowned landscape we've barely begun to explore. Some researchers think this catastrophic flooding of the Black Sea is the origin of the biblical flood story. The timing works, the scale certainly matches, and populations fleeing from the expanding sea would have carried their memories with them, stories of a great flood that swallowed the world their ancestors knew. But the Black Sea wasn't unique. Similar dramas were playing out on coastlines all around the world. Consider Doggerland. Today, Britain is an island, separated from continental Europe by the English Channel and the North Sea. But during the Ice Age you could walk from England to Denmark. The entire southern North Sea was dry land. Not just a narrow land bridge, but a vast lowland plain covering an area about the size of modern Britain. Rolling hills, river valleys, marshlands, forests. An entire country that doesn't exist anymore, and people lived there. Hundreds of fishing trawlers working the North Sea have pulled up archaeological remains. Stone tools, bone artifacts, the remains of extinct megafauna. all of it dredged from what used to be above water. Each artifact represents a moment in someone's life. A hunter manufacturing a spear point, a woman processing animal hides, a child playing near a riverbank that's now under 120 feet of ocean. Doggerland didn't drown all at once either. It died slowly, generation by generation. First, the low-lying areas became marshland as the water table rose. Then the marshes became lagoons. The lagoons merged into bays. River valleys that had flowed east toward the Rhine Delta became estuaries, then straits. High ground became islands. Islands became shoals. Shoals disappeared beneath the waves. The final blow came around 8,200 years ago. That's when a massive underwater landslide off the coast of Norway, probably triggered by earthquakes as the crust rebounded from the weight of melted ice, generated a tsunami that swept across what remained of Doggerland. The Storegga Slide, geologists call it. It displaced something like 800 cubic miles of seafloor sediment. The resulting wave was up to 80 feet high in some areas. Any communities still living on the remaining islands of Doggerland would have been annihilated. The archaeological record simply stops. Within a few more centuries, the last high points vanished and Britain became an island. The English Channel that had been a river valley became a sea strait. An entire nation, an entire culture gone beneath the waves, leaving almost nothing behind but a scatter of artifacts accidentally preserved in marine sediments. The same pattern repeated across the world. In Southeast Asia, the Sunda Shelf connected modern Indonesia, Malaysia, and parts of Indochina into a single landmass called Sunderland. It was enormous, adding something like 1.8 million square kilometers to the available land surface. That's an area bigger than Alaska, just gone. And it wasn't marginal territory. Tropical coastlines during the Ice Age would have been incredibly productive. Coral reefs, mangrove forests, rich river deltas, some of the highest biological diversity on the planet. The populations living here probably developed sophisticated maritime cultures thousands of years before their inland cousins. They would have had boats, fishing technologies, probably extensive trade networks connecting different islands and peninsulas. As sea levels rose, the Sunda Shelf fragmented. First it broke into large islands, then those islands subdivided. Communities that had been connected by land suddenly found themselves separated by expanding sea straits. Some adapted, developing better boats and longer-range seafaring capabilities. Others became isolated, cut off from trade networks and cultural exchange. By about 10,000 years ago, the basic shape of modern Southeast Asia had emerged, but those rising seas had submerged the ancient heartland of the region. If there were major population centres, sophisticated cultures, early cities on Sunderland, they're now under hundreds of feet of tropical ocean. We'll probably never know what was lost. The same thing happened on the Sal Shelf connecting Australia, New Guinea and Tasmania. During the Ice Age they were one continuous landmass. The rising seas separated them, creating the Torres Strait between Australia and New Guinea and the Bass Strait between Australia and Tasmania. Aboriginal oral traditions actually preserve memories of these flooding events. Stories passed down for 10,000 years about lands that were once connected, islands that vanished, coastlines that retreated. That's remarkable when you think about it. Cultural memory persisting for 400 generations, maintaining accurate geographical information about changes that happened when your ancestors' were alive. It suggests these weren't just abstract stories. They were vital survival knowledge about how rapidly landscapes could change, how the sea could rise and swallow entire territories. In the Persian Gulf, the transformation was equally dramatic. During the Ice Age, the Gulf barely existed. It was a river valley, an extension of the Tigris and Euphrates system that flowed south through what's now the Gulf and emptied into the ocean somewhere near the Strait of Hormuz. The valley floor was hundreds of miles long and probably quite fertile, fed by rivers draining the Zagros Mountains and the Arabian interior. Archaeological evidence is scarce because it's all underwater now, but some researchers think this river valley might have been one of the early centers of agriculture and animal domestication. The timing works. The environment would have been ideal. And the Sumerian flood myths, some of the oldest written stories in human history, describe a great deluge that destroyed the world before kingship descended from heaven. As sea levels rose, the lower Persian Gulf flooded relatively quickly. The gradient was gentle, which meant even small increases in sea level could flood vast areas. Within a few thousand years, that entire river valley had become a shallow sea. Any populations living there would have been pushed north and west into Mesopotamia, where they eventually developed what we recognize as the first civilizations: Sumerian, Akkadian, Babylonian. Were these civilizations built by climate refugees? People whose ancestors had been driven from drowned homelands, carrying with them advanced knowledge of agriculture, architecture, and social organization. It's impossible to prove, but the flood myths suggest they remembered something catastrophic about their origins. The creation of the English Channel tells a similar story on a smaller scale. Before it flooded, southern Britain was connected to France by a land bridge. The Thames and the Rhine were tributaries of the same river system, flowing into the Atlantic somewhere west of where the channel is now. Archaeological sites on both sides show similar cultures, the same tool technologies, probably the same language families. But as sea levels rose, this connection became tenuous. First, it narrowed to a thin isthmus. Then, probably around 6,500 years ago, catastrophic flooding broke through. There might have been a glacial lake ponded in the southern North Sea, held back by a chalk ridge connecting Dover to Calais. When that ridge failed, perhaps undermined by rising seas or shattered by earthquakes, the lake drained catastrophically, carving the channel in what might have been a matter of weeks. This wasn't just about drowning land, it was about severing connections. Populations that had been part of a single cultural network suddenly found themselves on opposite sides of a widening sea strait. The continental and British cultures began diverging immediately. Different evolutionary pressures, different environmental challenges, different solutions. Within a few thousand years, the separation would be obvious. Different languages, different social structures, different genetic profiles. But here's what makes all of this truly haunting. The process was slow enough that people could see it coming, but too fast to stop. Think about what that must have been like. You're living in a coastal village. Your family has been there for generations, maybe centuries. You know, from the stories the elders tell that the sea has been advancing. Your grandfather talks about lands that are now islands. His grandfather talked about when those islands were hilltops in a continuous plain. You can measure it yourself if you're observant. That marker stone your ancestors set up to record high tide. Every few years, high tide reaches a little farther inland. That spit of land you used to walk to reach the fishing grounds, now you need a boat. The marsh you played in as a child. It's a lagoon now, too deep to wade across. You could move, obviously. Pack up everything, abandon the homes your ancestors built, and retreat inland. But to where? The good territories inland are already occupied. Other people who got pushed out by earlier sea level rise, refugees who arrived generations ago and established their own communities. There's competition for every viable territory, sometimes violent competition. So you stay. You adapt. You build your houses on higher ground. You develop better boats. You learn to exploit marine resources more efficiently. You watch the water rise and hope it stops. Hope that maybe this generation will be the last to see the sea advance, that your children or grandchildren might live in a stable world, but it doesn't stop. It keeps rising, slowly, relentlessly. And you realize with a sick certainty that someday, maybe not in your lifetime, but someday, there will be nothing left. Everything you know will be underwater. Your villages, your sacred sites, your burial grounds, the landscape your people have inhabited for hundreds of generations will cease to exist. That's the psychological horror of slow catastrophe. It's not dramatic enough to trigger immediate emergency response. It's just persistent enough to become the new normal, generation after generation watching their world shrink, and knowing with absolute certainty that it will continue shrinking until nothing remains. Coastal populations during this period faced an impossible choice: stay and eventually drown, or abandon everything and compete for inland territories against people who were already there and wouldn't welcome refugees. Many chose to stay until the last possible moment. Archaeological evidence from drowned coastal sites shows continuous occupation right up until the sea finally swallowed them. But millions must have left. Waves of climate refugees pushing inland, carrying with them whatever they could save. Their knowledge, their technologies, their stories. These migrations would have destabilized existing populations, created conflict, but also transmitted innovations. Coastal fishing technologies spreading inland, maritime trade networks extending to river systems, boat-building techniques adapted for inland waters. Some of these refugee populations probably became conquerors, using their superior technologies to displace inland peoples. Others integrated peacefully, their skills and knowledge making them valuable to existing communities. Still others were probably destroyed, unable to find new territories and unwilling to abandon the coasts until it was too late. And through all of this, the water kept rising. 6 inches per decade on average, but concentrated in pulses that could be far more dramatic. Meltwater pulse. 1A around 14,600 years ago raised sea levels by 50 feet in less than 500 years. That's over an inch per year, fast enough to watch coastlines retreat in real time. Meltwater pulse 1B around 11,300 years ago added another surge of rapid rise. By 7,000 years ago, the worst was over. Sea levels stabilized near modern levels. The continental shelves were drowned. The coastal plain civilizations were gone, but their descendants survived, carrying forward memories of the ancient world, stories about lands beneath the waves, floods that swallowed everything, a time when the waters rose and never stopped. Those stories would become the flood myths we know today. Different cultures, different continents, but the same basic narrative. There was a time before when the world was different. Then came the waters, and when the waters receded, everything had changed. The old world was gone forever. They weren't just myths. They were memories of the drowning of the ancient world, passed down through hundreds of generations by the descendants of people who watched it happen. Here's something that should make you pause. Right now, as you're listening to this, there are over 200 different cultures around the world that tell stories about a great flood. 200. Societies separated by oceans, mountains, and thousands of miles, many of which had no contact with each other until recent centuries. Yet they all remember the same thing: water rising, the world drowning, nearly everyone dying except a chosen few. Coincidence? Maybe. But here's the thing about oral traditions. They're not random. They don't just make up catastrophes for entertainment. Flood myths are remarkably specific, remarkably consistent, and they show up in places where major flooding would have been absolutely devastating to early human settlements. So let's talk about what humanity remembers. What stories survived 12,000 years of retelling, getting passed down generation after generation, changing languages, crossing continents, but keeping the same core truth. The world flooded. Nearly everyone died, and somehow we survived. The oldest written version of the flood story comes from ancient Mesopotamia, from what is now Iraq. It's called the Epic of Gilgamesh, and it was inscribed on clay tablets around 4,000 years ago. But the story itself is older, much older. The Sumerians were telling this tale at least 5,000 years ago, and the events it describes happened even earlier than that. In the epic there's a character named Utnapishtim. He's basically the Mesopotamian Noah. The gods decide to destroy humanity with a catastrophic flood because people have become too numerous and too noisy. But one god, Ea, warns Utnapishtim. He tells him to tear down his house and build a boat. Not just any boat, a massive vessel sealed with pitch and bitumen, big enough to hold his family, craftsmen to preserve human knowledge, and representatives of every living thing. Sound familiar? It should, because this is essentially the same story that would later appear in the Hebrew Bible as Noah's Ark. But here's what makes the Mesopotamian version so interesting. It's geographically specific. Utnapishtim's flood happens in the region between the Tigris and Euphrates rivers, precisely the area that would have been catastrophically affected by rising sea levels at the end of the Ice Age. When the glaciers melted and the Persian Gulf filled, it didn't happen slowly and predictably. It happened in surges, sudden rises in sea level that would have sent massive floods up the river valleys where the first human civilizations were developing. To people living in settlements along those rivers, it would have seemed like the entire world was drowning. The biblical version is more familiar to most people. Noah, the righteous man in a corrupt world. God decides to wipe out humanity, but gives Noah specific instructions. Build an ark, make it 300 cubits long, 50 cubits wide, 30 cubits high, seal it with pitch. Bring your family and breeding pairs of every animal. Then it rains for 40 days and 40 nights. The waters rise for 150 days. Everything dies except what's on the ark. Finally the waters recede. The ark lands on Mount Ararat. Noah sends out a dove that returns with an olive branch, proving dry land has emerged. God promises never to flood the world again. For thousands of years, people debated whether this was literal history or metaphor. But here's what's interesting. Take away the theological elements, the divine judgment and the covenant with God, and you're left with a remarkably accurate description of what would happen during a catastrophic flood event. Sustained rainfall, yes, but more importantly, rising waters that inundate everything. A period of maximum flooding that lasts for months, then gradual recession as the waters drain or evaporate, mountains emerging first as the water level drops, and finally the return of vegetation symbolized by that olive branch. This is exactly what we'd expect from rapid sea level rise at the end of the Ice Age. The rain might have been the original storyteller's attempt to explain where all the water came from. They didn't have the concept of glaciers or ice sheets. They just knew that water fell from the sky, so a world-ending amount of water must have come from incredibly massive rainfall. But here's where it gets really fascinating. The flood story isn't unique to the Middle East. Travel to India, and you find the Hindu story of Manu. In this version, Manu is a righteous king who saves a small fish from being eaten by a larger one. The fish grows enormous and warns Manu that a great deluge is coming. Manu builds a boat, and when the flood comes, the fish, now revealed as the god Vishnu, tows the boat to safety on a mountain peak. After the flood, Manu becomes the father of a new humanity. Different details, different gods, same basic story. Catastrophic flood. Divine warning. One man builds a boat. Nearly everything dies. Humanity gets a fresh start. Go to China and you encounter the legend of Gun Yu. A massive flood threatens to destroy civilization. Gun tries to stop it by building dams but fails. His son Yu succeeds by dredging channels to control the water flow. The Chinese version is interesting because it preserves a different detail. It's not just about surviving the flood, it's about the engineering response to it. Managing water, creating irrigation systems, building the infrastructure that would allow civilization to flourish after the catastrophe. This might reflect a real historical response to post-Ice Age, flooding in the Yellow River Valley. As waters rose and drainage patterns changed, early Chinese societies would have needed to develop sophisticated water management systems. The legend of Yu might be the cultural memory of that critical adaptation period. The Greeks had their version too. Zeus decides to destroy humanity because of their wickedness. He causes a catastrophic flood. Only Deucalion, son of Prometheus, and his wife Pyrrha survive by building a chest, a floating box, and climbing inside. They float for 9 days and nights until the waters recede, and they land on Mount Parnassus. They repopulate the earth by throwing stones over their shoulders that transform into people. Again, the core elements are there. Flood destroys the world. 2 survivors, boat or floating vessel, landing on a mountain, repopulation of the earth. The details change based on Greek cultural beliefs about the gods and about how life could be created, but the framework is identical to stories from Mesopotamia, India and China. Cross the ocean to the Americas, and the pattern continues. The Ojibwe people of North America tell of a time when the world was covered in water. Wisekejak, a trickster hero, is floating on a raft with various animals. He sends animals diving down to find Earth. Muskrat succeeds, bringing up a small amount of mud which Wisekejak uses to recreate the land. The Aztecs believed the world had been destroyed and recreated multiple times. One of those destructions was by flood, a catastrophe that wiped out an entire world age before the current one began. South American tribes from the Andes to the Amazon have flood stories. The Mapuche people of Chile tell of a battle between 2 serpents that caused the sea to overflow, drowning nearly everyone. Survivors fled to high mountains. The Yanomami of the Amazon describe a great flood that forced ancestors to take refuge in caves in the highlands. What's remarkable isn't just that these stories exist, it's how specific they are about certain details. The water rises suddenly and catastrophically. It's not a predictable seasonal flood, it's an event unlike anything in living memory. Mountains or high ground become refuges. Water-based transportation, boats, rafts, floating vessels becomes essential for survival. A small number of people survive to restart humanity. And critically, this event marks a before and after in human history. The old world is destroyed, a new world begins. These are not the characteristics of mythological stories created for moral instruction. They're the characteristics of cultural memories trying to preserve information about a real event. Anthropologists have documented how oral traditions can preserve accurate historical information across incredible time spans. Aboriginal Australians have oral histories that describe coastlines and islands that haven't existed for over 10,000 years since the end of the Ice Age. When researchers checked these stories against geological evidence, they found them remarkably accurate. The stories described specific places that are now underwater, places that have been submerged since sea levels rose after the glacial melt. If Aboriginal Australians can preserve accurate geographical information for 10,000 years through oral tradition, why couldn't Mesopotamians, Indians, Chinese, and Native Americans preserve memories of catastrophic flooding that happened during the same period? The mechanism for this preservation is actually well understood. Important information gets encoded in stories that are ritually repeated, often word for word, generation after generation. The stories become sacred, which means the culture develops mechanisms to ensure accurate transmission. Elders who can recite them perfectly hold positions of authority. Changes to the stories are discouraged or forbidden. Details get locked in through rhythm, repetition, and association with important cultural practices. Over time, the context might be forgotten. People might not remember why a particular detail is important, but the detail itself survives because the story survives. Eventually, the story becomes myth, becomes religion, becomes something people believe in without necessarily thinking it describes real historical events. But the memory remains, encoded in narratives that have been refined by thousands of retellings, preserved by cultures that understood, even if unconsciously, that these stories contained information too important to lose. And here's what's really striking. When you map flood myths against geological evidence of post-Ice Age flooding, you find correlations. Mesopotamian flood myths correspond to the flooding of the Persian Gulf and the inundation of river valleys when sea levels rose. Mediterranean flood myths align with the catastrophic flooding when the Black Sea filled, an event that happened around 7,500 years ago, when rising sea levels caused the Mediterranean to breach a natural dam and pour into a massive freshwater lake. In a matter of months, maybe even weeks, the Black Sea rose by hundreds of feet, drowning countless settlements along its shores. Native American flood myths from the Pacific Northwest describe waters rising and mountains appearing, consistent with the end of Ice Age conditions along the coast, where glacial melt and land subsidence dramatically altered the landscape. Chinese flood myths correspond to the period when the Yellow River Valley was subject to catastrophic flooding, as glacial meltwater changed drainage patterns and sea level rise pushed water up river valleys. This doesn't mean every detail of every flood myth is historically accurate. The gods, the moral lessons, the supernatural elements, these are cultural additions, the framework each society used to make sense of the catastrophe. But the catastrophe itself appears to be real. What we're looking at is humanity's collective memory of the end of the Ice Age, the period between 15,000 and 11,000 years ago, when melting glaciers, collapsing ice dams, and rising sea levels created the most dramatic environmental changes human beings had ever experienced. For people living through it, it must have seemed like the end of the world, and in a sense it was. The world they knew, the coastlines they'd lived on for thousands of years, the river valleys where their ancestors had settled, all of it disappeared underwater. Whole landscapes were erased. Entire populations were displaced. Knowledge was lost. Settlements were abandoned. But some survived. Small groups who made it to high ground, who built boats, who adapted to the new world that emerged from the flood. And those survivors told their children what had happened. And those children told their children. And the story spread, changed, adapted to different languages and different cultures, but always keeping the same core truth. The world flooded, We almost didn't make it, but we did, and we remember. That's what these myths are, not primitive superstition, not Bronze Age fantasy. They're history, preserved in the only medium available to preliterate peoples, oral tradition, refined by thousands of retellings, encoded in stories sacred enough that people fought to preserve them exactly as they received them. When we dismiss flood myths as mere mythology, we're ignoring 200 independent cultural testimonies about the same event. That's not how evidence works. When 200 witnesses all describe the same thing, you don't dismiss them. You start investigating what they saw, and what they saw, what they lived through, what they barely survived, was the greatest environmental catastrophe in human history since our species emerged. The flood that ended the Ice Age, the drowning of the ancient world, the event that forced humanity to either adapt or die. We adapted, and we remembered. For 12,000 years we've been telling the story of how we survived. Now, finally, we have the geological evidence to prove it wasn't just a story. But here's the thing about catastrophic floods that happened 12,000 years ago. They don't leave witnesses. They don't leave written records. They don't leave convenient plaques saying massive climate disaster happened here. What they leave are scars. Physical evidence buried in ice, hidden in ocean sediment, carved into the landscape, waiting for someone smart enough to read the story they tell. And scientists have become very good at reading those stories. The first breakthrough came from the most unlikely place imaginable. Not some dramatic archaeological dig or underwater exploration. It came from drilling holes in ice. In the 1960s, researchers started extracting ice cores from Greenland and Antarctica. Long cylinders of frozen water, sometimes stretching 2 miles deep, each layer representing a single year of snowfall going back hundreds of thousands of years. Ice cores are basically time capsules. As snow falls and compresses into ice, it traps tiny bubbles of ancient atmosphere, dust particles from distant volcanic eruptions, pollen grains blown from forests that don't exist anymore, chemical signatures from ocean spray when sea levels were different. Every layer is a snapshot of what Earth's climate was like during that specific year. When researchers first analysed ice cores from the end of the Ice Age, they expected to see gradual changes, slow, steady warming as the planet transitioned from frozen to temperate. That's not what they found. Instead, they discovered something that shouldn't have been possible. Around 12,800 years ago, temperatures in Greenland dropped catastrophically. Not gradually over centuries, but fast. We're talking about temperature changes of 15 degrees Celsius in less than a decade. Some climate shifts happened in less than 3 years. You could literally watch your world transform from temperate to Arctic winter within your own lifetime. The ice cores showed this cold snap, the younger Dryas, lasting about 1,300 years. Then, just as suddenly, it ended. Around 11,600 years ago, temperatures shot back up. The warming was even faster than the cooling. In some regions, average temperatures increased by 10 degrees Celsius in less than 50 years. Some estimates suggest the shifts happened in as little as 3 years. Think about that. 3 years. That's not climate change as we usually imagine it. That's a climate emergency. 1 year you're dealing with brutal winters that last 8 months. 3 years later, ice sheets that have existed for millennia are melting so fast you can hear them groaning and cracking from miles away. But ice cores only tell part of the story. They show temperature changes, atmospheric composition, precipitation patterns. What they don't show is what was happening in the oceans. For that, scientists needed different evidence. They needed ocean sediment cores. The ocean floor is like a giant filing system. Sediment rains down constantly. Dead plankton, dust from continents, volcanic ash, minerals precipitating from seawater. Layer by layer, year by year, century by century, it accumulates. Drill down into that sediment, and you're drilling through time itself. In the 1980s, oceanographers started pulling sediment cores from the North Atlantic, the Gulf of Mexico, the Mediterranean Sea. What they found was shocking. Around 11,600 years ago, right at the end of the Younger Dryas, ocean sediments show massive pulses of fresh water. Not gradual increases, but sudden, enormous injections of meltwater that fundamentally altered ocean salinity. The evidence is written in the chemistry of microscopic shells. Foraminifera, tiny organisms that build shells from minerals in seawater. The ratio of oxygen isotopes in their shells depends on the temperature and salinity of the water they lived in. When scientists analysed foraminifera shells from sediment layers dating to the end of the Younger Dryas, they found dramatic shifts in isotope ratios, shifts that could only be explained by massive amounts of fresh water suddenly entering the ocean. We're not talking about normal glacial melt here. We're talking about catastrophic freshwater pulses equivalent to all the Great Lakes being dumped into the ocean in a matter of years or decades. The kind of event that would have shut down ocean currents, altered global climate patterns, and raised sea levels by meters in a geological eye blink. But where was all this freshwater coming from? The answer lay in reading the scars carved into the landscape itself. In the 1920s, a geologist named J. Harlan Bretz started exploring the channeled scablands of eastern Washington state. What he found shouldn't have existed. Massive channels carved through bedrock, giant ripples in the landscape some 40 feet high and 300 feet apart, boulders the size of houses sitting in places where no glacier could have deposited them, and all of it speaking to one impossible conclusion. This landscape had been scoured by the largest flood in recent geological history. Bretz proposed that a massive ice dam had held back an enormous glacial lake, Lake Missoula. When that dam failed, the lake drained catastrophically. Hundreds of cubic miles of water unleashed in a matter of days. The flood would have been 200 meters deep in some places, moving at speeds of up to 100 kilometers per hour. It scoured away hundreds of feet of soil and sediment, carved channels through solid bedrock, and transported massive boulders hundreds of miles downstream. His colleagues thought he was crazy. Floods don't carve landscapes. Rivers do, gradually, over millions of years. But Bretz was right, and over the following decades, evidence for his catastrophic flood became overwhelming, and Lake Missoula wasn't alone. As glaciers melted at the end of the Ice Age, ice dams failed across the northern hemisphere. Massive glacial lakes, some larger than modern seas, drained catastrophically. Lake Agassiz in North America was larger than all the current Great Lakes combined. When its ice dams failed, probably multiple times, it sent biblical quantities of water rushing toward the oceans. Some researchers believe one catastrophic drainage event from Lake Agassiz dumped so much fresh water into the North Atlantic that it shut down the Gulf Stream, triggering the Younger Dryas cooling. Then, when warming resumed and ice dams failed again, the resulting floods would have raised global sea levels by several meters in just decades or centuries. The physical evidence for these megafloods is everywhere once you know how to look for it. In Siberia, researchers have found similar scabland features. In the Altai Mountains, there are massive gravel bars and erosional features, carved by catastrophic floods from glacial Lake Chuja. In the Himalayas, there's evidence of massive glacial lake outburst floods, all dating to the same general period at the end of the Ice Age. But perhaps the most dramatic evidence comes from beneath the oceans themselves. In the 1990s, something remarkable happened. Marine archaeologists, using increasingly sophisticated sonar technology, started finding human settlements underwater. Not shipwrecks, not artifacts that had fallen off boats, actual settlements, houses, streets, walls, tools, all sitting on continental shelves that are now 100 feet or more beneath the waves. Off the coast of India, researchers discovered the remains of what might be the ancient city of Dwarka, mentioned in Hindu epics as being swallowed by the sea. Underwater surveys revealed organized stone structures, walls, a possible harbour, all submerged beneath the Arabian Sea. Carbon dating of recovered materials suggests the site was occupied during the period when sea levels were rapidly rising. In the Mediterranean, underwater archaeologists have found numerous submerged settlements off the coasts of Greece, Turkey and Italy. Sites that were clearly built on dry land, occupied for generations, then abandoned as rising waters made them uninhabitable. Some show evidence of hasty evacuation, tools and pottery left behind as people fled rising seas. Off the coast of Japan, the controversial Yonaguni monument presents what some researchers argue are carved stone structures, including what looks like terraces, roads, and angular formations that seem too regular to be natural. Whether it's a natural formation or human-made is still debated, but if it's artificial, it was carved when sea levels were much lower, then submerged as the Ice Age ended. Perhaps most intriguingly, researchers have identified what they call Doggerland, a now submerged landmass that once connected Britain to continental Europe. Using seafloor mapping, they've reconstructed an entire lost landscape. Rivers, lakes, hills, coastlines, all now beneath the North Sea. Trawler nets occasionally pull up stone tools, animal bones and other artifacts from this drowned world. Evidence of a landscape where people lived, hunted, and built communities before the oceans rose and swallowed everything. But the evidence isn't just underwater. In 2007, researchers studying the Black Sea discovered something extraordinary. The Black Sea was once a freshwater lake, sitting about 150 meters lower than it is today. Around 7,600 years ago, as sea levels rose following the Ice Age melt, the Mediterranean breached a natural barrier at what is now the Bosporus Strait. Seawater poured into the Black Sea basin in what must have been one of the most dramatic floods in human history. The evidence is written in sediment cores from the Black Sea floor. There's a clear boundary layer, a distinct transition from freshwater lake sediments to saltwater ocean sediments. The dating is precise. The transition was catastrophic. Some researchers estimate the Mediterranean was pouring into the Black Sea basin at 200 times the flow rate of Niagara Falls. The water level was rising by 6 inches per day. Coastal settlements around the lake would have been underwater within weeks. Some researchers believe this catastrophic flood is the source of the biblical flood myth and similar stories from cultures around the Black Sea region. If you were living on the shores of what you thought was a lake, and suddenly that lake became an ocean in a matter of months, drowning everything you knew, you'd remember it. Your descendants would remember it. It would become the story you tell around fires for thousands of years. The geological evidence for rapid sea level rise doesn't end with dramatic floods and submerged settlements. It's also written in the locations of things that shouldn't be where they are. marine fossils in the Sahara Desert, thousands of miles from any ocean, whale skeletons in the mountains of Egypt, seashells in caves hundreds of feet above current sea levels. These aren't evidence of the Ice Age floods directly. They're evidence of the longer timeline of sea level change. When the Ice Age was at its peak, sea levels were 120 meters lower than today. As the ice melted, oceans rose, swamping vast coastal plains that are now continental shelves. The marine fossils in unexpected places mark the high water points of ancient seas, evidence that our planet's geography has been radically different within the timescale of human history. Modern satellite technology has added another dimension to reading Earth's scars. Synthetic aperture radar can penetrate jungle canopy and even detect subtle changes in surface elevation invisible to the naked eye. Using this technology, researchers have discovered river channels beneath the Sahara Desert, ancient water systems that existed when the region was green and habitable. They've mapped ancient coastlines now far inland or underwater. They've identified lake basins that held massive bodies of water during wetter periods, then dried up catastrophically. In North America, satellite imagery combined with ground surveys has revealed the full extent of the scablin features Brett's discovered. Channel systems carved by megafloods extend for hundreds of miles. The ripple marks, basically underwater dunes created by flowing water, are so large they're only visible from space. Some of these ripples are 50 feet high. The amount of water needed to create features this large is almost incomprehensible. Carbon dating has been the crucial tool tying all this evidence together. Organic materials, wood, charcoal, plant remains, seeds, anything that was once alive, can be dated with remarkable precision using carbon-14 analysis. When researchers date materials from tsunami deposits, megaflood sediments, or the boundary layers between glacial and post-glacial periods, a clear timeline emerges. The younger Dryas cold period began around 12,800 years ago. It ended catastrophically around 11,600 years ago. The megafloods from Lake Agassiz and Lake Missoula date to this transition period. The rapid sea level rise that submerged coastal settlements happened over the following millennia, with some catastrophic pulses as remaining ice dams failed. The Black Sea flood happened later, around 7,600 years ago, as rising oceans breached natural barriers. But here's what makes all this evidence compelling. It's not coming from one source or one discipline. It's a convergence. Glaciologists studying ice cores, oceanographers analysing sediment, geologists mapping ancient flood channels, archaeologists finding submerged settlements, climatologists modelling atmospheric changes, all of them independently arriving at the same conclusion. Something dramatic happened at the end of the Ice Age. Something fast, violent and transformative. The multidisciplinary approach has been crucial because no single line of evidence tells the whole story. Ice cores show temperature changes but don't explain mechanisms. Sediment cores show freshwater pulses but don't reveal the scale of flooding on land. Archaeological evidence shows human responses but doesn't explain the underlying climate drivers. Only by combining all these disciplines, cross-referencing their findings, checking their dates against each other, do we get the full picture. And that picture is terrifying and fascinating in equal measure. Earth's climate isn't stable. It doesn't change gradually. Under the right conditions, it can flip from one state to another in a matter of years or decades. Ice sheets that seem permanent can collapse catastrophically. Sea levels that have been stable for centuries can rise by meters in a single human lifetime. Landscapes that have supported civilizations can become uninhabitable with shocking speed. The scars are there if you know how to read them, carved in bedrock, buried in ice, hidden in ocean sediment, submerged beneath rising seas. They tell a story of a world transformed, of catastrophic changes happening so fast that the planet itself barely had time to adjust. And they tell us something important about our own time, our own warming climate, our own melting ice sheets. This has all happened before. Earth knows how to do this. The question is whether we're ready for what comes next. But here's where the story gets really interesting, because those floods, that catastrophic melting that drowned coastlines and reshaped continents, they didn't just destroy the old world, they created the foundation for everything that came after. Every civilization you've ever heard of, every empire, every city, every technological leap that would eventually lead to the device you're listening to this on right now, all of it traces back to what happened when the ice walls broke 12,000 years ago. Think about it. Before the floods, humans had been living essentially the same way for tens of thousands of years. Small nomadic groups, maybe 20, 30 people, following animal herds, gathering seasonal plants, moving constantly to exploit resources as they became available. They had sophisticated tools, complex language, impressive hunting strategies, but they were still fundamentally mobile, still living in temporary camps, still moving with the seasons and the game animals. Then the water came. Not all at once, not everywhere, but relentlessly. Year after year, decade after decade, the coastlines where many of these groups had been living, the rich river valleys, the productive lowlands, all of it went underwater. And humans did what they'd always done when catastrophe struck. They moved. But this time, there was nowhere else to go. The Ice Age megafauna, the giant mammals that had sustained human populations for millennia, they were dying off. Some killed by the rapid climate change, others hunted to extinction by humans who were suddenly competing for dwindling resources. The easy life of following mammoth herds across open grasslands was ending. The comfortable coastal settlements with their abundant seafood and mild climates were drowning. Humans were being forced into smaller and smaller areas of habitable land. And here's the thing about forced migration. It concentrates populations, those small bands of 20, 30 people. They started encountering other groups more frequently, not just occasionally during seasonal gatherings, but constantly, competing for the same hunting grounds, the same water sources, the same territories that weren't underwater. This created a problem. For tens of thousands of years, human social systems has been designed for small groups, extended family units that could maintain cooperation through kinship bonds. When conflicts arose between groups, you could just move apart. There was always somewhere else to go. But now, suddenly there wasn't. The habitable world was shrinking. Groups that had been able to avoid each other were now forced into proximity. They had two choices: fight or cooperate. And while fighting certainly happened, the archaeological record from this period shows something else emerging, something unprecedented in human history. Large-scale social organization beyond kinship groups, multiple bands coming together, not just for seasonal gatherings but permanently, developing rules and systems for living together, creating what anthropologists call tribal structures. But cooperation at this scale requires something that nomadic life had never demanded. It requires staying in one place long enough to build relationships, establish hierarchies, develop shared identities, and that meant settling down. The forced concentration of populations created by the floods was pushing humans toward permanent settlements. But permanent settlements require something that following herds never did: food storage. When you're nomadic, you eat what you kill or gather, then you move on to the next resource. There's no point in accumulating more than you can carry. But when you're living in one place year-round, you need to survive the lean seasons. You need to store food. And here's where the real transformation began. Stored food needs to be guarded. It attracts raiders. It creates inequality because some families will have more stored than others. It demands social structures to manage distribution and prevent theft. Within just a few generations, these settling populations were developing chiefdoms, leaders who controlled food storage, warrior classes to defend resources, craftspeople who could specialize because they didn't have to spend all their time hunting. This is the birth of social complexity, the beginning of everything we would eventually call civilization. And it all traces back to those rising floodwaters, forcing people into tighter and tighter spaces. But there was another change happening simultaneously, one that would prove even more important: agriculture. Now, humans had been managing wild plants for thousands of years, protecting useful species, maybe doing some light transplanting. But actual farming, systematic cultivation of domesticated crops that emerged suddenly around 10,000 years ago, right in the aftermath of the floods. This wasn't coincidence. The catastrophic flooding had created ideal conditions for agriculture in very specific locations, river valleys. As the massive Ice Age lakes drained and sea levels rose, rivers all over the world were adjusting to new drainage patterns. Annual flooding became predictable, sediment deposited by floodwaters enriched soil. And humans who had been forced to settle near these rivers because the coastal areas were drowned, they noticed something. Seeds that fell in the flood zone after the waters receded grew better than seeds anywhere else. The annual flood cycle created natural irrigation and fertilization. All you had to do was scatter seeds after the water retreated and come back a few months later to harvest. It was almost like the rivers were farming for you. The first agricultural societies emerged in exactly these flood-prone river valleys. The Fertile Crescent between the Tigris and Euphrates rivers, the Nile Valley in Egypt, the Indus River in what's now Pakistan, the Yellow River in China. These weren't accidents. These were the places where the post-flood geography had created conditions where agriculture was not just possible, but almost inevitable. And agriculture changed everything. For the first time in human history, food production could be scaled up beyond immediate consumption. One farmer could produce enough grain to feed themselves and several other people. This freed up portions of the population to do other things, build structures, make pottery, develop metalworking, create art, write. Within just a few thousand years, which is nothing in archaeological terms, these river valley settlements were transforming into something the world had never seen. Cities. Mesopotamia developed the first urban centers, places like Uruk and Ur, with populations in the tens of thousands. Egypt unified along the Nile and began building monuments that still stand today. The Indus Valley civilization created planned cities with sophisticated drainage systems. China developed writing systems and bronze working. This is what archaeologists call the Neolithic Revolution, the transition from mobile hunting and gathering to settled agriculture and urban life. And it happened, not gradually over hundreds of thousands of years like previous human adaptations, but explosively. Within just 5,000 years of the Great Floods, humans had gone from small nomadic bands to massive urban civilizations with writing, mathematics, monumental architecture, standing armies, and complex religious systems. But here's what's really wild about this transformation. All these early civilizations, despite being separated by thousands of miles and developing independently, they all face the same core challenge: water management. Because those annual floods that made agriculture possible, they were also incredibly destructive. Too much water and your crops drowned, your villages washed away. Too little water and everything died of drought. The first engineers weren't building pyramids or palaces, they were building levees, irrigation canals, drainage systems, flood control barriers. Every early civilization invested enormous resources in controlling water flow. The Mesopotamians developed sophisticated canal networks that could redirect floodwaters to distant fields. The Egyptians built nilometers to measure flood heights and predict harvest yields. The Indus Valley people created urban drainage systems more advanced than some modern cities. This wasn't just practical engineering. This was civilization-defining work. Controlling water flow required centralized planning, large-scale labor coordination, mathematical understanding of flow rates and volumes. It demanded record-keeping systems to track water distribution. It created powerful bureaucracies to manage the infrastructure. In very real ways, the first governments were water management authorities. And all of this traces directly back to the floods. The catastrophic melting had created a world where human survival depended on managing water flow. The societies that figured this out flourished. Those that didn't disappeared into archaeological obscurity. Natural selection was now operating at the level of civilizations. But the floods had another, more subtle effect on human civilization. They created a psychological scar that would echo through every culture that came after. Remember, this wasn't some distant event that humans heard about second-hand. This was lived experience, passed down through oral traditions for generations. Your great-great-great-grandmother telling stories about the old coastal settlements that had been swallowed by the sea. The fertile lowlands that were now underwater, the animals that had vanished, the people who had drowned. Every early civilization developed flood myths. The story of Noah's Ark in the Middle East, the Epic of Gilgamesh in Mesopotamia, which predates the biblical account and tells remarkably similar stories. The Hindu texts describing Manu surviving a great deluge. Chinese legends of Gunyu taming the floods. Greek myths of Deucalion and Pyrrha, Native American stories of world-destroying waters. These aren't just similar by coincidence, they're cultural memories of real events. But more than just memories, these flood myths shaped religious thinking in fundamental ways. They introduced the concept of divine punishment through natural disaster. The idea that gods could destroy the world and remake it. The notion that humanity's survival was contingent on proper behavior and divine favor. This is the birth of apocalyptic thinking, the psychological framework that would influence human religion and philosophy for the next 10,000 years. The floods also created something else, a profound sense of loss. Because here's what we tend to forget when we talk about the rise of civilization. Something was lost in the transition. The Ice Age world that drowned beneath those rising seas wasn't primitive. It was sophisticated in ways we're only beginning to understand. Those coastal settlements that went underwater, they had been occupied for thousands of years. The archaeological sites we find inland, they're just the survivors. The sites we don't find, the ones now under 400 feet of ocean, they probably represented the most developed and successful human settlements of the Ice Age. Coastal areas with abundant resources, mild climates, easy water transportation. If you were going to develop sophisticated culture and technology, you'd do it at the coast. All of that is gone now, drowned beneath the continental shelves. We're missing perhaps 90% of the archaeological record of late Ice Age humanity. Everything that was built within 50 miles of the old coastline is underwater, covered by sediment destroyed by 12,000 years of ocean currents. The knowledge those coastal peoples had developed, their technologies, their cultural achievements, their understanding of the world, most of it was lost when the waters rose. The people who survived, who fled inland and upland, they carried what they could. Oral traditions, basic technologies, social structures, but the complex knowledge built up over millennia of coastal settlement, specialized fishing techniques, boat-building traditions, sophisticated understanding of tides and currents, that was gone. Lost beneath the waves like Atlantis in the myths. This means that the civilizations we see emerging after the floods, impressive as they weren't building on a blank slate. They were rebuilding, reconstructing human culture from whatever fragments had survived the catastrophe. Some knowledge was preserved. Tool-making techniques, fire management, basic social organization. But other knowledge had to be rediscovered from scratch. Maritime technology, complex architecture, large-scale social coordination. In very real ways, the floods reset human cultural development. Not completely. We didn't go back to being primitive apes, but we lost a massive portion of accumulated knowledge and had to spend thousands of years rebuilding to get back to where we'd been. And who knows what technologies or insights those drowned coastal civilizations had developed that we've never recovered? What was lost that we don't even know we're missing? But maybe, just maybe, that loss created the conditions for something new. Because those post-flood river valley civilizations, they weren't just rebuilding the old world. They were creating something unprecedented. The concentration of populations, the development of agriculture, the need for water management, the psychological impact of surviving catastrophe. All of these factors combined to push human social evolution in directions it had never gone before. Cities larger than any previous human settlement. Writing systems that could preserve knowledge across generations. Mathematics sophisticated enough to predict flood cycles and calculate harvest yields. Religious systems that grappled with humanity's place in a world that could be destroyed and remade. Art and architecture on scales that would have seemed impossible to Ice Age peoples. Political systems capable of coordinating the labor of thousands toward common goals. This is the foundation of everything that came after. Every empire, every technological revolution, every cultural achievement of the last 10,000 years, it all traces back to those desperate groups of humans fleeing rising floodwaters and figuring out how to survive in a transformed world. We're all living in the aftermath of the flood, all descendants of the survivors who learned to build civilizations on ground high enough to escape the waters, all products of the catastrophe that ended the Ice Age and began the Age of Cities. The question is, what would those drowned coastal peoples think if they could see what we've built on the ruins of their world? Would they recognize the distant descendants of the refugees who fled inland? Would they be proud of what we've achieved? Or would they mourn everything that was lost when the ice walls broke and the old world drowned? We'll never know, but their legacy lives on in every flood myth, every river valley civilization, every city built with one eye on the water level, remembering the day when the ocean rose and changed everything. So here we are, at the end of a story that spans 12,000 years, from the frozen world of the Ice Age to the warmer, wetter planet we inherited. From ice sheets 2 miles thick covering half the northern hemisphere, to rising seas that drowned entire landscapes and erased coastlines that humans had called home for thousands of years. It's a lot to process. Because what happened 12,000 years ago wasn't just one event, it was a cascade, a domino effect of catastrophes that each set the next in motion. First, the ice sheets began melting, not slowly, not gradually, but in sudden pulses as massive ice dams failed and released floods that would dwarf anything in recorded history. Then came the sea level rise. 400 feet over just a few thousand years, entire continental shelves disappearing beneath the waves, coastlines retreating miles inland every human lifetime, valleys becoming bays, plains becoming seafloors, the geography of the world being redrawn by forces beyond anyone's control. And through it all, humans survived. Not just survived, actually. They adapted, they moved, they built. They told stories about the rising waters that would echo through their descendants' cultures for 10,000 years. That's what this story really reveals about our species. We're survivors of climate catastrophe. Not in some abstract sense, not theoretically, literally. The modern world exists because our ancestors weathered the greatest environmental transformation since the end of the dinosaurs. They watched their world drown and found a way forward anyway. But here's what keeps me up at night. They had advantages we might not have. When the seas rose 12,000 years ago, there was somewhere to go. The interior continents were mostly empty. Hunter-gatherer populations could move inland, find new territories, establish new hunting grounds. The planet wasn't full yet. Today, we've got 8 billion people, concentrated cities, political borders, agricultural systems dependent on stable climate patterns. When the seas rise now, and they are rising, where exactly do we go? Bangladesh is already losing land. Pacific islands are already planning evacuations. Florida's coastline is already experiencing regular flooding during high tides. The parallels are uncomfortable. Our ancestors faced climate change driven by natural cycles, orbital mechanics, and solar variations they couldn't control. We're facing climate change driven by our own industrial activity, something we can theoretically control but seem politically incapable of addressing. They watched ice sheets collapse and coastlines drown. We're watching ice sheets in Greenland and Antarctica lose mass at accelerating rates. They saw sea levels rise 400 feet over millennia. We're projected to see several feet of rise within this century alone. The difference is speed and scale. The post-glacial flooding happened over thousands of years, multiple human lifetimes. Communities had generations to adapt, migrate, adjust. What we're facing now could happen within single lifetimes. Children born today might live to see changes that would have taken dozens of generations 12,000 years ago. But there's also reason for cautious optimism in this ancient story, because it proves something fundamental about human adaptability. We've survived catastrophic climate change before, not just survived, but used the crisis as a catalyst for innovation. The flooding of the coastal lowlands pushed humans to develop new technologies, better boats for fishing and transport, new agricultural techniques for different environments. Eventually, the population concentrations that made civilization possible. The Great Flood didn't destroy humanity. It transformed us, forced us to become more innovative, more cooperative, more capable of long-term planning. The question is whether we can channel that same adaptive capacity now, whether we can face our own climate crisis with the resilience and creativity that carried our ancestors through theirs. And let's be honest, we still don't know everything. Mysteries remain. There are underwater sites off coastlines around the world that haven't been properly explored. Settlements that were drowned 12,000 years ago still waiting to tell their stories. Technologies that were lost when the craftspeople who created them fled rising waters. maybe even civilizations more sophisticated than we've imagined, erased by floods before they could leave permanent records. Every year, new discoveries reshape our understanding. New underwater archaeology revealing submerged landscapes, new ice core data showing more complex climate patterns than we thought, new genetic evidence suggesting human populations were larger and more interconnected than previous estimates. The story of the Great Flood isn't finished. We're still uncovering it. Still learning what really happened when the Ice Age world drowned and the modern world emerged from the waves. But what we do know is extraordinary. 12,000 years ago, our ancestors lived through changes that would terrify us today. They adapted, they survived, they built the foundation for everything that came after. We are their descendants, products of that ancient resilience, carriers of genes that survived catastrophe. Maybe that means we've got what it takes to face what's coming. Maybe the lessons written in flood myths and drowned coastlines can guide us through our own climate challenges. Or maybe we're about to learn that survival isn't guaranteed, that civilizations can be as fragile as coastlines when the waters rise. Either way, the story matters, because understanding what happened 12,000 years ago helps us understand who we are and what we might become. Thanks for joining me on this journey through deep time. If you enjoyed this dive into ancient catastrophe and human survival, hit that like button and subscribe for more history to help you drift off to sleep. And leave a comment telling me where in the world you're listening from as you fall asleep tonight. Are you near a coast that was once dry land? In a valley that was once beneath the waves? Sweet dreams. And remember, our ancestors survived a drowned world. Their story lives in us.